Hello guys, hope you are all doing good. So let's see how we can dive into the question you sent. So in the question you have a diagram looking like this. So we have the final velocity, which is 16 meters per second. Here we have a t. So this is time, then here is speed. So here we have something like this. So now let's start answering. So from the question, there is a part which is saying from here to there it's 40. From here to here, this distance or the time interval here is 40 seconds. I don't know if you've seen that, but here we have 40 seconds. Then from rest, it accelerates with the speed of 2 meters per second. So let's just indicate there 2 meters per second squared. Then papa is 0 from rest. So the first question is saying find the value of t. So to find the value of t, we are going to use the formula for velocity, which is v is equal to initial velocity plus acceleration times time. Then what's our final velocity? Our final velocity is 16, so we replace with 16 there. Then our initial is 0 plus our acceleration is 2 meters per second multiplied by time. So we're going to have 16 is equal to, this is 0, same as nothing, so we're just going to say 2t, then over 2, then time is equal to 80 seconds. This is the value of the TA. Then question B, the second question is saying, it's telling us to find the distance traveled in the last 50 seconds. So again, if you've seen from the question, there is a statement which is telling us that the time interval from here to there, it's 10 seconds. The time for deceleration, you're going to check from the question. Here we have the time interval of 10 seconds. Then from what we've just from answering here, the t here it's 8. So the time interval from here to there is 80. From here to there it's 40. From here to there it's 10 seconds. So now the question is saying the distance traveled in the last 50 seconds. So in the last, meaning we are going to start counting from here. This is 10 plus 40, it's 50. So that they are talking about this distance from here to here. So we're going to get this. We're going to have something like something like this. So this shape is parallelogram. I don't know if that's the correct pronunciation. But that is. So parallelogram has two shapes, the rectangle or square and the triangle. So to calculate the distance, you can either split it or just combine it and come up with the answer. So we have the rectangle. So the rectangle, when we find the distance, we multiply the height, which is 16 times 40. Then for the triangle, it's the distance is half 10 times the height 16. Then you are going to combine the answer you are going to get. So it's 80, 640. The answer is 720 meters. That's the final answer for B. So let's now go to the last question, question C. So the first thing, as you can see, from here to there it's 8, then from here to there it's 40. So from here to there it's 48. So you're going to indicate 48. Then since there it's 10 seconds, meaning from here to there it's what? It's 58. Then the question is saying, it's telling us to find the speed of the car when time is equal to 53 seconds. So you're just going to ask yourself, why is 53 seconds from the given diagram? So of course, since this is 48, this is 58, 53 has to be between this and this. So we're just going to indicate should be between this and this. So we have to find the velocity here. Then the time, this is 53. Again, you're going to ask yourself, what's the time interval between 48 and 53? Of course, it's 5 seconds. So the way we handle questions from this part is different from the way we handle questions from this part, because here it was accelerating, then here it was decelerating, So here we had acceleration, meaning here we have to find the deceleration. So let's now find the deceleration. Deceleration is the opposite of acceleration. So acceleration is equal to our initial velocity here is from here, then our final is here. But when it comes to acceleration, the initial is here, the final is there. But once it starts decelerating, as we are saying, it's the opposite. So this is the initial, this is the final. So acceleration is equal to final minus initial over time. So acceleration is equal to our final is 0, then our initial is 16 over the time interval here is 10. So acceleration is equal to negative 16 divided by 10, it's negative 1.6 meters per second squared. This is our deceleration. If we try to collect the data, up to now we have the acceleration, which is deceleration, is equal to negative 1.6 meters per second squared. We also have the time, which is 5, the time from here to there is 5 seconds. What else? The initial velocity. The initial velocity is equal to 16 meters per second. Then we're going to find the final. We're talking about opposite things. This one here is our final. So this is what we are looking for. So here we have 16 the initial. So we're going to use the formula for velocity. Velocity is equal to initial plus 80. So 16 sorry, this is what we are looking for. This is what we have. This is 16. So V is equal to 16 plus our deceleration is -1.6, then time is 5. V is equal to 16 minus this multiplied by this, it's -8. So velocity equal to 8 meters per seconds. This is our final answer. Yeah. If you have any questions, you can ask. Yeah.